In this video, we're going to do a couple more examples working with ellipses, and one where it might actually be a circle. So let's remember that an ellipse has a center like a circle, but it's kind of a stretched out circle. So one side might have a longer radius than another side. So the side, the diameter that's the longest, this is called the major axis. And the diameter that's the shortest is called the minor axis. Okay, and then the way we define an ellipse is with these foci, but we're not actually going to use those, so you don't have to worry about that. So remember that this is the standard form for the equation for an ellipse. So it's like the equation for the circle, except that it equals 1. And then we have these a squared and b squareds under our perfect squares for x and y. So if it's in this form, then you have center, HK, like we do for circles. And the A and the B give you the radius of each of these major and minor axes. Okay, so you can't tell which one's the major and which one's the minor. Those go with whichever one is bigger. Okay, so in this first picture, A is bigger, so A is the major axis, and B is the smaller one, so it's the minor axis. But in this picture, B is the bigger one, so it's the major, and A is the minor. Okay, so let's do an example. So here, we want to graph the ellipse with the center at the origin. Okay, so that center at the origin tells us that HK is equal to 0, 0. Okay, so we get that right away. A y-intercept is at 0, 3, and a vertex is at 5, 0. So remember, the vertex is where the major axis meets the ellipse. Okay, so we can just start plotting. Let's just draw a grid here. That's not straight at all. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we know we have a point at 5, 0. So we can plot that. And we know we have a point at 0, 3. Okay, so we can plot that. Okay, and we know that the center is at 0, 0. So we know that this is the major axis. Okay, so we know that A is 5, which means that we should go 5 in this direction. We should have another point. Okay, at negative 5, 0. Which means that this is the minor axis. So that means we should go 3 this way to find another point as well. Okay, so our ellipse here is going to look something like that. Okay, now for the equation, so we know the HK is 0, 0. We know the A is 5 and the B is 3. So that means our equation is going to be x minus 0 squared over 5 squared plus y minus 0 squared over 3 squared is equal to 1. So that's going to be x squared over 25 plus y squared over 9 is equal to 1. So that would be the equation for this ellipse. Okay, so the A goes with the x, the B goes with the y. Okay, let's try another one. So for each of these, we want to determine whether it's a circle or an ellipse. Okay, so we can, and then we're going to rewrite it in standard form and give the graph. So here, the coefficient in front of the x squared and the y squared are the same. Okay, so we have, so this, if you look at the before, when it's in this form, which this one is, A and B are equal, so that means this is a circle. Okay, so A equals B, which implies this is, a circle. Okay, so then when we want to solve for a circle, so everything's divisible by 2, so we could factor out a 2. Even if it wasn't, we could still factor out a 2. Okay, then you could divide everything by 2. That's going to cancel. So then we have x squared plus 2x plus y squared plus 4y minus 4 equals 0. Okay, so now I want to complete the square, so here and here. So I'm going to add, half of 2 is 1, so I'm going to add, I'm going to add 1 and subtract 1, that's the square of 1. Now over here, half of 4 is 2, so I want to add 2 squared and subtract 2 squared, and then I have this other minus 4 as well. Okay, then we're going to just bracket them so that we have our perfect squares together. So this is going to be x plus 1 all squared minus 1, and this one's going to be y plus 2 all squared, and then I have minus 4 minus 4. Putting all the numbers together, I have minus 9 on this side, so if I move that to the other side, I get equals positive 9. And this is the standard form for a circle. So we don't have to equal 1 here. That's for ellipses. So here we want to equal r squared. So this we know the center of this circle is minus 1 minus 2, and the radius is the square root of 9, which is 3. Okay, so if we wanted to draw the circle, okay, so I have the x and the y. Okay, so I'm going to plot or mark the center, so that's -1, -2. So that's my center. And then I'm going to go out 3, 1, 2 to the right, and 3 vertical, and 3 to the left, and 3 down, and that's where all my points are going to be. Okay, so this point over here is at 2, -2. This one's going to be at -4, -2. Here I keep the -1, and it's -1, 1. And here it's -1, -5. And then we can just connect these, and we get a circle. Okay, so that would be our graph for part A. Okay, in part B, now if we look at the coefficients in front of the x squared and the y squared, they're not equal. So A does not equal B, so this one is going to be an ellipse. Okay, so again, I'm going to just pull out the 4 from the x terms. So that's x squared plus 4x. Okay, we just have the y squared, no other y's. So I just need to complete the square here. This one, the y is already a perfect square. Okay, so for the x, I need to add 2 squared and subtract 2 squared. It needs to be inside that bracket. Okay, so then I'm going to get x plus 2 all squared minus the 4. So maybe I should just show you those are those brackets. So that goes together to be the perfect square. And then I have to put the 4 through to both terms. So I get 4 x plus 2 all squared minus 16 plus y squared plus 12. Okay, now negative 16 plus 12 is negative 4. If I move that to the other side, it's going to be a positive 4. And then I want the right-hand side to be 1, so I'm going to divide everything by 4. Okay, so that's going to give me x plus 2 squared over 1, okay, plus y squared over 4 equals 1. And this is actually in the standard form, because this is x plus 2 squared over 1 squared. This one is y minus 0 squared over 2 squared equals 1. Okay, so it's going to have center of negative 2, 0. The a for the x is 1, and the b for the y is 2. So our major axis is for the y. So let's just graph it over here. Okay, so the center is at negative 2, 0. So that's our center. In the x, we're going to go 1 in each direction. And in the y, we're going to go 2 in each direction. So I get a point at negative 3, 0, and a point at negative 1, 0. And then I have a point at negative 2, 2, and a point at negative 2, negative 2. And then I get my ellipse here. Okay, so that's what the graph of that one would look like. Okay, but here's the equation in standard form. Okay, or this one is just as good, but it doesn't, just to illuminate what all the bits are. So that's working with ellipses and their equations and their graphs.